Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter alcohols, phenols and ethers. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them. Um, Also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that anisole can be prepared by the action of methyl iodide on sodium phenate. Now anisole means which is m- m- methoxybenzene is called anisole. So it can be prepared by reacting methyl iodide with sodium phenate means Na plus OPH minus. This OPH minus, this is called the phenate ion. So it is sodium phenate. So it reacts with methyl iodide to form the anisole. So it is called the Williamson's reaction. Williamson's reaction. So here the reaction follows the SN2 mechanism. It follows SN2 mechanism, and here any alkoxide RO minus Na plus that reacts with the substrate, which is R dash, and here we have the leaving group. So this leaving group will be removed, and this OR minus, which is the alkoxide, that will attack R dash, and one ether will be formed, ROR dash, and sodium ion will be linked with the leaving group. So here one ether will be formed. So it is the mechanism of the Williamson reaction. So option D is the correct answer. Then here it is told that catalytic dehydrogenation of primary alcohol gives a catalytic dehydrogenation. So here primary alcohol that will lose one hydrogen to form an aldehyde, R-CHO. So primary alcohol, primary alcohol will lose one hydrogen to form the aldehyde. So option D is the correct answer. Then among the following, which one is least acidic? Now we have paranitrophenol, paranitrophenol, and we have parachlorophenol, parachlorophenol, and we have phenol, and we have orthocresol. Orthocresol is like this, which is orthomethyl phenol. So which one of the following is the least acidic that has been asked? So here this NO2 and Cl, these are the electron withdrawing groups. Electron withdrawing groups, since they have got minus R effect or minus M effect, and they have got minus I effect also, the negative inductive effect. And this uh, methyl group, it has the plus I effect, which is the positive in inductive effect. So it will um, so when electron withdrawing groups are attached to the benzene ring, then it will decrease the electron density in the ring in the ortho and in the para positions. So in the ortho and in the para positions, the electron density will be decreased. Electron density will be decreased. And so the acidic character will increase. It means that more easily it can give out the H plus ion. So when the electron density in the benzene ring is decreased in the ortho and in the para positions, then the acidic character will increase. So it means that the para nitrophenol, it has more acidic character than parachlorophenol, and which is more acidic than phenol, which is more acidic than orthocresol. So orthocresol is the least acidic. So option D is the correct answer. Here, since why here the plus I effect, it will increase the electron density in the ring. So hence the acidic character will be decreased. Then here it is told that the best method for the conversion of an alcohol into alkyl chloride. Alcohol is converted into alkyl chloride is by treating the alcohol with by treating the alcohol with SOCl2. in in presence of pyridine. So here the advantage of this method is, here the advantage of this method over using the phosphorus chlorides, which is PCl3 or PCl5, is that the is that the byproducts which are formed here, the byproducts formed are sulfur dioxide and hydrogen chloride, which are gases and which can easily escape from the reaction mixture. Since these SO2 and HCl which are formed, SO2 and HCl which are formed as the byproducts, these are gases and hence can easily escape out. So it means that using SOCl2 in the presence of pyridine is the best method for the conversion of an alcohol into an alkyl chloride. So option B is the correct answer. Then here it is told that Lucas test is associated with So the Lucas test is associated with alcohols. So the Lucas test, it is used to distinguish in between, is used to distinguish in between the primary alcohols or 1 degree alcohols and secondary or 2 degree alcohols and tertiary or 3 degree alcohols. So here so in the Lucas test for alcohols, the Lucas reagent is used, which is the concentrated HCl and the anhydrous zinc chloride. So it is added to the alcohols to form the alkyl chloride, and the formation of the alkyl chloride, it results in the appearance of turbidity. It results in the appearance of turbidity, appearance of turbidity in the solution. So if the so if 3 degree alcohol is used, then this alkyl chloride is immediately formed. It means the turbidity also will be immediately formed. And if 2 degree alcohol is used, then the alkyl chloride is formed after some 5 to 6 minutes. So when the alkyl chloride is not formed immediately, it means that it is a 2 degree alcohol. So here the turbidity is also formed after 5 to 6 minutes. And if 1 degree alcohol is used, then the solution remains clear. It means here no turbidity will be formed. Here no turbidity is formed. So hence it is a 1 degree alcohol. So the Lucas test is used to distinguish the degree of the alcohol. So option C is the correct answer. So here it is said that 1 mole of an organic compound A with the formula C3H8O reacts completely with 2 moles of HI, hydrogen iodide, to form X and Y. When Y is boiled in aqueous alkali, it forms Z. Z answers the iodoform test. So Z gives iodoform test. So now, then the compound A is. So it is C3H8O. So it should be an ether, since it reacts with HI. So the compound A should be an ether only. So it should be CH3O, CH2, CH3, which is ethyl methyl ether, and that reacts with 2 moles of HI to form CH3I and C2H5I and H2O. Now this is X, this is Y, and Y will give iodoform test since this is C2H5I, that will when it is boiled with aqueous alkali, means aqueous KOH, potassium hydroxide, then it will form ethyl alcohol or ethanol. Now ethanol will give iodoform test. So hence the compound A is, we can say it is methoxyethane. Methoxyethane. So option D is the correct answer. Then here it is told an oxygen containing organic compound upon oxidation forms carboxylic acid as the only organic product with its molecular mass higher by 14 units. The organic compound is. So the, as you can see that the difference in the mass, the difference in the masses of the CH2OH group and the carboxylic acid group is how much? So for CH2OH group, the mass M1, that is 12 plus 3 plus 16, which is 15 plus 16, which is 31 units. And for COH group, the mass M2 is 12 plus 16 to the 32 plus 1, that is 13. Okay, 12 plus 33, that is 45 units. So it means here the difference in the masses of the CH2OH group and the COOH group is 45 minus 31, that is equals to 14 units only. So hence we can say, hence the organic compound, the organic compound is the primary alcohol, is the primary or 1-degree alcohol which gets oxidized to the carboxylic acid, which upon oxidation, forms the carboxylic acid. So it means that it should be a primary alcohol. Option B is the correct answer. Then here it is told that phenol uh, phenol, which is benzene ring with the alcohol group, and with X it forms a tribromo derivative. So it will react with 3Br2 to form with H2O to form tribromo phenol from tribromo plus 3HBr. So it is 2, 4, 6, 1, 2, 3, 4, 5, 6. So it is 2, 4, 6 tribromo phenol. So here X is bromine in water. So bromine in water should be used. So option B is the correct answer. here it is told identify B and D in the following sequence of reactions. So when ethene, which is CH2H2, it reacts with concentrated H2SO4, then it forms A. The compound A will be CH3CH2 HSO4, which is the compound A. Here what will happen, that there will be heterolytic cleavage. There will be heterolytic cleavage. So then this pi electrons will go here, and here one carbocation will be formed, and here one carbon ion will be formed, CH2 minus and CH2 plus. Then from H2SO4, HSO4 minus ion and the H plus ion will be formed. This H plus ion will combine with the carbon ion, and this HSO4 minus ion will attack at the carbocation. Then it will form CH3 CH2 HSO4. Then if it is heated in with H2O, then it will form. So if it is heated with H2O, then OH group will be linked with. So from H2O we will have OH minus ion and H plus ion. H plus ion will get linked with HSO4 minus ion, and it will again form H2SO4, and OH minus ion will attack here in the carbocation. Then it will form the ethanol, CH3CH2OH, which is the compound B. And then when it reacts with PBr3, then then OH minus will be substituted with Br minus ion. So it will form CH3CH2 Br, which is bromoethane. So which is a compound C. And when again it is reacted with alcoholic KOH, then there will be dehydrohalogenation, and then it will produce CH2CH2. The alkene will be formed. So here we have to identify B and D. So B is ethanol, B is ethanol, and D is alcoholic KOH, alcoholic potassium hydroxide. So option D is the correct answer. Then here it is told the compound which gives turbidity immediately with Lucas reagent at room temperature is. The compound which gives turbidity immediately with Lucas reagent at room temperature. So Lucas reagent with Lucas reagent, the turbidity is obtained immediately if a 3-degree alcohol is used. The turbidity is obtained immediately. Turbidity is obtained immediately if we use a 3-degree alcohol, or I can say a tertiary alcohol. Tertiary alcohol. So the first one is butane 1-ol. Butane 1-ol, which is this. So it is a 1-degree alcohol. So it will not give turbidity with the Lucas reagent. And B is butane 2-ol, which is a 2-degree alcohol, which will not give turbidity immediately, but here it will give turbidity after a short time, like after 5 minutes it will give. After 5 minutes it will give turbidity. So, and option C, it is 2-methyl propan 2-ol. So it is propan 2-methyl propan 2-ol. Yeah, so it is a 3-degree alcohol. So it will give the turbidity immediately with the Lucas reagent. And in option D, it is 2-methyl propan 1-ol. 2-methyl propan 1-ol. So it is also a 1-degree alcohol. So it will not give turbidity. So option C is the correct answer. And Lucas reagent, it means that it is concentrated HCl with anhydrous zinc chloride. Concentrated HCl with anhydrous zinc chloride is called as Lucas reagent. Then here it is told that power alcohol is a mixture of power alcohol. So a mixture of, the rule is that a mixture of 20% ethanol, C2H5OH, and 80% gasoline, 80% gasoline or petrol is called as power alcohol. Is called as power alcohol, and it is used in the internal com, com, combustion engines to provide mechanical power. So it is used in the internal combustion engines. Used in the internal combustion engines to provide mechanical power. So 20% ethanol with 80% petrol, and with a small quantity of benzene, C6H5, small in small amounts. So option B is the correct answer. And identify C in the following. So here the benzene reacts with CH3CH, CH3Cl. It means that it is isopropyl chloride that reacts with benzene in the presence of anhydrous aluminum chloride, AlCl3, with HCl. Then, so anhydrous AlCl3, and it will remove HCl from here. Mm, then one carbo cation will be formed here. Yeah. So it means that from here hydrogen will be removed, and from here Cl will be removed. Then when hydrogen is removed, then here one negative charge is formed. Then here CH3CH plus is formed. So then this nucleophile will attack here. Then it will form CH3, CH3, which is isopropyl benzene. It is isopropyl benzene is formed, or it is also called cumene, which is the compound A here. And then it reacts with oxygen in 130 degree Celsius to produce the compound B, which is when it reacts with oxygen, then one a peroxide will be formed, which is like this, which is called as cumene hydroperoxide. Cumene hydroperoxide will be formed, which is the compound B here. And then again it will react with dilute sulfuric acid, dilute H4 in at 100 degrees Celsius to produce phenol, and C, the compound C. Now the compound C will be this, which is acetone. The compound C is the acetone, or it is called propanone. Propanone or acetone will be formed. So the compound C has been asked, which is propanone. So option C is the correct answer. Then it is told which of the following is strongly acidic. So option A, we have phenol. This is phenol. And B, we have orthocresol, which is methyl group is attached in the ortho. This is called cresol. And then we have paranitrophenol. Paranitrophenol. Here the nitro group is attached, which is the C1. This is option A. This is option B. And D is paracresol, which is like this. Paracresol, and this one is paranitrophenol. So the nitro group, it has got, so it is an electron withdrawing group. Electron withdrawing group is attached. So which will have negative resonance effect minus R effect. So it will decrease the electron density in the ortho and in the para positions. So this nitro group, it will decrease the electron density in the ortho and para positions in the benzene ring. So hence it will increase the acidity. So it will increase the acidic strength of phenols. So it increases the acidic strength of the phenols. So hence option C is the correct answer. That the C1 is the, so paranitrophenol is the most acidic. It means that it can most easily it can give out one H plus ion from here. Then it is told that the aldehyde, which is CH3 E double bond OH. Okay, so which is an aldehyde group. That will react with CH3MgBr, which is ether, and which forms A. So in the presence of ether, it will form C CH3 CH3, and this CHO, which is the aldehyde group, it will change into CO minus MgBr plus, and from here we will have CH3 minus and MgBr plus. So CH3 group will be attached here. Then in the presence of H3O plus or H2O and H plus, it will give H plus here. Then H plus ion will link with O minus, then it will form OH. So it will form CH, CH3, CH3, CH, CH3, and here OH plus MgOH Br. So it will form 1, 2, 3, 4. So it is 3 methyl butan 2 all. 3 methyl butan 2 all will be formed, which is the compound B, and this one is the compound A. So option A is the correct answer. Then here it is told the OH group. So okay, the phenol, it reacts with benzoyl chloride with a base which is called as ben, benzoylation. Benzoylation it is called. It is phenol, and then one it will produce OC6H5. It is called as phenyl benzoate, which is the compound X. And then on nitration, nitration means that here uh, concentrated H2SO4, so concentrated HNO3 with H2SO4 is used to produce. So it will give one NO2 group in the para position. So it will give one NO2 group in the para position, and this will be OOC6H5. So it will form 4. So 1, 2, 3, 4. So it is the compound Y, which is the major product that is formed. So its IUPAC name is 4 nitrophenyl benzoate. 4 nitrophenyl benzoate. So it will form. So if we draw its structure, then it will be like this: NO2, then benzene ring here. Then we have sorry, here O. Sorry, here COCl. So it will be here carbon also will be there. This will be carbon, sorry. be like this. So CO. Okay. So therefore the structure will be, this is COO, this is COO, then here one benzene ring, and here NO2. So this will be the structure of 4-nitrophenyl benzoate. So it is option A is the correct answer. Then it is told that 0.44 gram of a monohydric alcohol. Monohydric alcohol, it means that it has only one OH group. So 0.44 gram of this monohydric alcohol, when added to methyl magnesium iodide, methyl magnesium iodide, which is obviously an organometallic compound, in presence of ether, it will give, it li- liberates 112 centimeter cube of m- m- methane, which is CH4, at STP. And with PCC, so here it will form, and it will form Mg. So it means that this CH3 minus, it will attack here, and this, it will form MgOH, MgOHI here. Mm, uh, sorry, CH3, from here we will have H plus ion. So H plus ion will come out, and this OR minus, it will go with MgI plus, and CH3 minus will link with H plus, and it will form CH4. So it will be MgORI. So with PCC, the same alcohol reacts to give a carbonyl compound. It gives a carbonyl compound which gives silver mirror test, which gives silver mirror test, which means that this carbonyl compound, it should be an aldehyde only, should be an aldehyde, so it should form RCHO, and hence this alcohol should be a primary alcohol, since with PCC, when it gets oxidized, with PCC, the primary alcohols or 1-degree alcohols will be oxidized into aldehydes, and aldehydes only will give silver mirror test. So it is obviously a primary alcohol. So it means that in options A and C, they are 2-degree alcohols, or they are secondary alcohols. So they can't be the answers. So either it can be B or it can be D only. So we have to see that which one is the answer out of B and D. Now here, 112 centimeter cube at STP. So now, therefore, here, um, now 112 centimeter cube of methane It means that it is 112 by 22400. It means that it is 1 by 200 mole. So therefore 1 by 2 mass of the mass of 1 by 200 mole of the primary alcohol is 0.44 gram. Since here we can see that 1 mole of this primary alcohol will give 1 mole of methane. 1 mole of methane it will give. So therefore the molar mass of the primary alcohol is the molar mass of this primary alcohol, that will be 0.44 gram into 200, that will be equal to 88 gram. So 88 gram is the molar mass. Now out of options B and D, so for option B, here we have CCH3 whole thrice and CH2OH. So its molar mass will be equal to, here we have 3 plus 2, 5 carbons, so 5 into 12, plus we have 3 3 is 9, 9 plus 3, 12 hydrogens and 1 oxygen, which is 16. So that will be 12 5 is 60, 60 plus 28, that is equals to 88 gram. And in option D, it is given, it is CH3 whole twice, CH3 whole twice, and then you have CH2OH. So its molar mass will be equal to, here we have 2 plus 2, 4 carbons, so 4 into 12, plus we have 2 3 is 6, 6 plus 4, that is 10 hydrogens, plus 1 oxygen, that is 16. So this will be equal to 12 for the 48, 48 plus 26. So this will be equal to 14 4 6. So this is 74 grams. So hence option D is not the correct answer. Option B is the correct answer. Then here it is told that arrange the following compounds in the increasing order of their acidic strength. Arrange the following compounds in increasing order of their acidic strength. Here the first one is metanitrophenol. Metanitrophenol. Second one is metacresol. Metacresol. Then third one is phenol. And fourth one is M metachlorophenol. Metachlorophenol. So here we can see that nitro group has got both minus R effect and minus I effect. But here so here, since the nitro group has got minus R effect, so nitro group has minus R effect. So it is an electron withdrawing group. So this hydrogen will be more acidic. This hydrogen is more acidic here. And the methyl group, it has got plus I effect. So this hydrogen, it is less acidic than phenol also. So, and chlorine has got plus R effect and minus I effect. So here, since it is attached in the meta position, so it will have minus I effect. So it is this hydrogen is more acidic than phenol, but it is uh, less acidic than uh, nitrophenol. So therefore the order of the acidic strength, that will be the first one will be the highest, and then we have fourth one, and then we have third one, and we have the second one. So first more than 4. So here we have to write in the increasing order. So it will be 2, less than 3, less than 4, less than 1. 2 less than 3, less than 4, less than 1. So option D is the correct answer. Then it is told that in the reaction ethanol, which is CH3CH2OH, that reacts with PCl5 to give X. X means it is CH3CH2Cl, which reacts with alcoholic KOH. Here, so here there will be dehydrohalogenation. Dehydrohalogenation. So here it will form CH2CH2, which is the alkene, which is the compound Y. And then with H2S4 at room temperature, it will react with H2O heat to give Z. So then again the alcohol will be formed, this CH3CH2OH, which is Z. So the compound Z is ethanol, which is option D. So option D is the correct answer. Since by ethanol, I can show it like this in the uh, in the in the bond line structure. We can show it like this also. Then it is told which of the following compounds is most acidic. So the first one is CH2CH2OH, and this is Cl. This is Cl. Mm, then we have phenol. Then we have orthonitrophenol. Then we have orthocresol. Now this one will have minus R effect. So this hydrogen will be the most acidic, and here, so it will be more acidic than phenol also. And this one, the methyl group, it has got plus I effect, which is the positive inductive effect. So this hydrogen, it will be the least acidic. It will be less acidic than phenol also. And chlorine, it has got minus I effect here. So this hydrogen is more acidic than this orthocresol also. So it means the most acidic is the orthonitrophenol. So option C is the correct answer. Then it is told the reaction which involves dichlorocarbene as an electrophile is. The reaction which involves dichlorocarbene, dichlorocarbene as an electrophile. So now the me mechanism is that the OH minus ion that will react with the chloroform to produce H2O and CCl3 minus, which will give CCl2 plus Cl minus. Now this CCl2, it is called the dichlorocarbene, which is an electrophile, E plus. Okay. Now, and then there will be electrophilic substitution reaction of the phenol. So with phenol, the with phenol, this chloroform reacts in the presence of NaOH at 340 Kelvin. So here it will give O Na and CHO. Then in the presence of dilute HCl, it will give aldehyde and phenol group. So it is 2-hydroxybenzyl it will give. So here the m- mechanism is that from phenol, the phenoxide ion is obtained, and here there will be resonance. So then these pi electrons, it will attack on the electrophile, which is dichlorocarbene, and then it will produce the CCl2 minus here, and here this is the oxygen. Then this one will attack here, and this sigma electrons will come here, and these pi electrons will go to the oxygen atom. Then it will produce the phenoxide ion, and then CHCl2. Then it will react with 2 NaOH. Then it will form sodium phenoxide, and here the CHO group will be formed. And then in presence of dilute HCl, it will give H plus ion to form orthohydroxybenzyl dehyde. Orthohydroxybenzyl dehyde it will give. So it is called the Reimer-Tiemann reaction. It's called the Reimer-Tiemann reaction. So option A is the correct answer. Then here it is told that e ethanol C2H5OH is converted into ethoxyethane by heating it in concentrated H2S4 at 140 °C. Then ethoxyethane is formed and H2O will be obtained. And here ethanol should be used in excess. So here excess of ethanol should be heated with concentrated H2S4 at 140 °C to obtain ethoxyethane. So option A is the correct answer. Then here it is told which of the following orders is true regarding the acidic nature of phenol. Acidic nature of phenol. Now we have phenol and we have orthocresol, which is OHCH3, and then we have orthonitrophenol. Orthonitrophenol. Then so the here the nitro is attached in the ortho position, so it will have minus R effect, minus R effect, which is since why nitro is an electron withdrawing group, so it will increase the acidity of the phe- uh, phenols. So this hydrogen will be most acidic hydrogen, and here the methyl group, it has got plus I effect, which is the positive inductive effect. So it will increase the electron density in the benzene ring. So it will decrease the acidity of this hydrogen. So this is lesser acidic than phenol also. So it means that orthonitrophenol is the most acidic. Orthonitrophenol is most acidic. Then we have phenol, and the orthocresol is the least acidic. So orthocresol, phenol, then orthonitrophenol. So option B is the correct answer. And here it is told which of the following cannot be used to oxidize primary alcohols to aldehydes. So if you have 1 degree alcohol or primary alcohol ROH, then it has to be oxidized to alcohol. It has to be oxidized to aldehydes. So here, so primary alcohols can be oxidized to aldehydes with KMNO4 in aqueous or in alkaline medium. In aqueous or in alkaline medium can be used, or mm, okay, and and acidified KMNO4 will oxidize alcohols to carboxylic acids. So if acidic KMNO4 is used, then alcoholic, then the primary alcohols will directly oxidize this KMNO4 in the presence of H plus. It will oxidize it into carboxylic acids. So aldehydes will not be formed. So option C is the correct answer. And CrO3 in anhydrous medium can also be used, and pyridinium chlorochromate can also be used, and heating in the presence of copper at 573 Kelvin can also be used to convert primary alcohols to aldehydes. Then it is told the products formed during the following reaction are. So here we have a tertiary alkyl group here, which is the tertiary butyl group. Tertiary butyl group we have with the methoxide. So it reacts with HI in 373 Kelvin. Um, so here, then this the alkyl halide that will be formed, it will be formed with the tertiary alkyl group. The rule is that the alkyl halide which is formed, that will be formed with the tertiary alkyl group only, and CH3OH will be formed. Since why this I minus will attack here only, since why 3-degree carbocation is more stable. 3-degree carbocation is more stable than this methyl carbocation. So hence the I minus will attack here only. Since here the plus charge will be formed, and from here this OCH3 minus will come out, and it will link with this H plus to form CH3OH. So option A is the correct answer. Then it is told that phenol can be distinguished from ethanol by the reagent. So the rule is that phenol forms a white precipitate. Phenol forms a white precipitate with bromine water. With bromine water, it will form white precipitate, and it will yield 2,4,6 tribromophenol. 2,4,6 tribromophenol, which is a white precipitate, and um, and with e- ethanol, with e- ethanol um, or with any alkyl alcohols, it no reaction will take place with the reagent bromine water. With ethanol or with any other alkyl alcohols, no reaction will take place. No reaction will take place with the bromine water. So option A is the correct answer. Since why uh, phenol will form white precipitate with bromine water, and with ethanol there is no such reaction. Then it is told that when the vapors of tertiary butyl alcohol are passed through heated copper, when the vapors of tertiary butyl alcohol, vapors of tertiary butyl alcohol, this is tertiary butyl alcohol, so its vapors is passed through heated copper at 573 Kelvin with, so here H2O will be removed and it will form CH3, CH2, CH3. So it will form 2-methyl propene. 2-methyl propene will be formed. So it means that um, here there will be a dehydration reaction. There will be a dehydration reaction with when it is heated with copper to form an alkene. So option C is the correct answer. Then it is told what is the increasing order of the acidic strength among the following. So the first one is paramethoxyphenol. Paramethoxyphenol. The second one is paramethylphenol. Paramethylphenol. Third one is paranitrophenol. para-nitrophenol. So now here this nitro group, it will have minus R effect and minus I effect. So it will decrease the electron density in the benzene ring. So hence this hydrogen is the most acidic. So from here H plus can very easily come out. So this hydrogen is most acidic here, and methyl group, it has got plus I effect. So it is an electron donating group. So it will increase the electron density in the benzene ring. So it will reduce the acidity of phenols. So hence this hydrogen is less acidic than phenol, less acidic than phenol. And here this OCH3, which is the methoxy group, it has got plus R effect. It has got plus R effect. So it will also increase the electron density in the benzene ring, which will also reduce the acidity of this phenols. So hence this hydrogen is the least acidic, since uh, it can't easily come out in the form of H by H plus. H plus can't easily come out from here. So it means that the first one is the least acidic. Second, second one is slightly higher acidic than the first one, and the third one is the most acidic. So one less than two, less than three. So option C is the correct answer. So simply the rule is that electron withdrawing groups will increase the acidity of phenols. Electron withdrawing groups which has electron withdrawing groups means which have got minus R effect and minus I effect, that will increase the acidity, or it will increase the acidic strength of phenols. And if you have electron donating groups, it means that which has got plus I effect or plus R effect, that will decrease the acidic strength of phenols. Decrease the acidic strength of phenols. Then here it is told that the products X and Z in the following sequence are, the products X and Z in the following sequence are. So here the benzene, it reacts with propene. Benzene reacts with propene in with anhydrous AlCl3 in the presence of ether. It is heated to produce X. No, the X, that will be isopropyl benzene. Isopropyl benzene or cumene will be formed. CH3, CH3, and so which is X, so it is called as cumene, or it is the isopropyl benzene will be formed. Now this isopropyl benzene, when it is reacted with in oxygen with 130 degrees Celsius, then it will form cumene hydro peroxide, means it will form COOH, then CH3, CH3, and then the benzene ring here. So it is called cumene hydroperoxide. So which is Y, the compound Y. Now this compound Y, which is the cumene hydroperoxide, cumene hydroperoxide, that will react in the presence of uh, an acidic solution, an acidic solution, it is heated, then it will form so it will form phenol, will form phenol and acetone. Phenol and acetone will be formed, which is also called as propanone. Propanone or acetone will be formed. So it means this one is the Z. This propanone or acetone is the compound Z. So we have to identify X and Z. So it is cumene. Cumene is X, and the Z is the acetone. So cumene, or I can say it is isopropyl benzene. So isopropyl benzene and acetone will be formed. So option A is the correct answer. Then it is told match the following acids with their pKa values. Now first one is phenol, then second one is paranitrophenol, paranitrophenol, and then we have ethanol, sorry, we have ethanol, which is CH3CH2OH, and then we have picric acid. Picric acid is how is picric acid? So it is uh, the structure is like this, which is 2,4,6 trinitrophenol. So it is 2,4,6 trinitrophenol. It is also called as picric acid. Now here obviously we have one NO2 group, so the nitro group, it has got minus R effect and minus I effect, so it is an electron withdrawing group. So it will increase the acidity of this H, this phenol. So this is more acidic than phenol, more acidic than phenol, obviously. Now, in case of picric acid, we have got three NO2 groups, where two NO2 groups are in the ortho position, and we have one nitro in the para position. So it will have minus R effect and minus I effect. And this one is ethanol. Now here, in case of picric acid, even though three NO2 groups are attached, but here we have intramolecular hydrogen bonding with this hydrogen. Since why this hydrogen here, there will be a hydrogen bond here. So hence this hydrogen is less acidic, since here intramolecular hydrogen bond will be formed. So this is less acidic. So hence it means that the second one means that okay. So now the rule is that if the acidic strength if the acidic strength increases, the acidic strength is higher, then the acid dissociation constant, which is Ka value will be higher. And if Ka value is higher, then it means the pKa value will be lower. pKa value will be lower. It means that if the acidic strength is higher, the pKa value will be higher. If the acidic strength is higher, the pKa value will be lower. So now here in case of okay, so here even if intermolecular hydrogen bond is there, but here we have got three NO2 groups here. So it has more amount of m- m- minus R effect and minus I effect. So the picric acid is the most acidic. So it means the pKa value for the picric acid will be the least. It will be the least. So it means that D should match with 2. So the pKa value for picric acid should be 0.78. Since out of all these four values, the 0.78 value is the least. So it will be the pKa value for picric acid, since it is most acidic among uh, all these four alcohols. Okay, then and the so so it means the acidic strength o- o- order, if you see, the A is phenol and B is paranitrophenol and C is ethanol and D is picric acid. So the order of the acidic strength, that will be uh, picric acid will be highest. Then we will have the paranitrophenol, so B. Then we have the phenol. mm, Then we have phenol, and then we have e- ethanol. So it means the pKa value order will be the reverse of this, which is D less than B less than A less than C. So it means that D should match with 2. D should be having the least value for pKa, and the highest value should be for C, which is 1. So C should be 1 and A should be 3 and B should be 4. So it means that A should be 3, B should be 4, and C should be 1 and D should be 2. So 3, 4, 1, 2. So option A is the correct answer. Then it is told that which of the following can be used to test the acidic nature of ethanol. Which of the following can be used to test the acidic nature of ethanol? So The rule is that acidic nature of ethanol can be tested. Acidic nature of ethanol can be tested by using an active m- metal, an active metal like sodium. Since why? Since why on reaction with sodium, on reaction with sodium, evolution of hydrogen gas will take place. Evolution of hydrogen gas will take place. So to CS, so the ethanol, which is CaCH2OH, that will react with sodium to produce CH3CH2O minus Na plus, and plus H2 gas will be released. H2 gas will be evolved. So hence the sodium metal can be used to test the acidic nature of ethanol. So option D is the correct answer. Then it is told involved, the steps involved in the conversion of propan 2-ol to propan 1-ol are in the order. So here it is told the steps involved in the conversion of propan 2-ol to propan 1-ol. The steps involved in the conversion of propan 2-ol. Okay, propan, which is propan 2-ol to propan 1-ol, which is CaCH2 CH2OH. So this one is propan 1-ol, which should be obtained from propan 2-ol. So how it can be obtained? So first it is heated with PCl5. It is heated with PCl5 to obtain um, 2-chloropropane. 2-chloropropane will be formed. Then it is reacted with alcoholic KOH. It is heated produce to produce uh, propene. Sorry, this is CH. So here propene will be formed. Since why, if when alcoholic KOH is used, there will be dehydrohalogenation. Dehydrohalogenation, it means that here HCl will be removed and propene will be formed, and then we should use so here we will have hydroboration, or here we should have hydration. It means that H2O should be added. H2O should be added. It means that here we should add acid catalyzed addition of water should be used. Acid catalyzed addition of water, it means, which is called as hydration. So here this alkene will be oxidized into 1 degree alcohol, means propan 1-ol will be formed, H2CH2OH. Here propan 1-ol will be formed. So it means that the steps involved are, first we should heat it with PCl5, and then we should heat it with alcoholic KOH. Then we should do acid catalyzed, no, here acid catalyzed hydration of water. If we use, then propan 2-ol only will be formed. So here we should use hydroboration oxidation. Hydroboration oxidation should be used here. Sorry, there was something wrong here. Here hydroboration oxidation should be used. Then only it will form propan 1-ol. So it means that option B is the correct answer. Then here it is told, which of the following on heating gives an ether as the major product? Which of the following on heating gives an ether as the major product? So here in P it is C6H5 CH2Br plus CH3ONa, and when it is heated, that will obviously produce C6H5 CH2OCH3 and NaBr. So here an ether will be formed of obviously, and then in the part Q here C6H5 C6H5 CH3 C6H5 ONa plus CH3 Br, when it is heated, then it will produce C6H5 OCH3 plus NaBr. And in the part R, when CH3 whole thrice CCl that is heated with CH3ONa, then here this O minus, this CH3O minus, it will attack here. Then so here the ethers will not be formed, since why it is a 3 degree or tertiary alkyl halide. Tertiary alkyl halide. So the rule is that alkoxides or phenoxides will react with alkyl. So they will always react with alkyl halides through SN2 mechanism only. Through SN2 mechanism only. So here in the case of 3 degree alkyl halide, here we have more heavier groups attached to it. So here there will be no reaction, since there is more steric hindrance due to these heavier groups. So there will be no SN2 reaction with this methoxide, no SN2 reaction with methoxide due to high amount of steric hindrance. High amount of steric hindrance. So it means that only the P and Q will give ethers, and the R will not give e- ether. So option C is the correct answer, that both P and Q will give ethers and R will not give an ether. Only P and Q will give. Then it is told that a compound A, which is a compound A whose molecular formula is C7H8O, is insoluble in sodium hydrogen carbonate. So it is insoluble in NaHCO3 solution, but it dissolves in sodium hydroxide, but dissolves in NaOH, and it gives a characteristic color with neutral FeCl3 solution. So it gives a characteristic color with FeCl3 solution. So with ferric chloride, when treated with bromine water C7H8O, when it is treated with bromine water, it forms the compound B with the molecular formula C7H5OBr3. Then the compound A is. So C7H8O. So in C7H8O, it means we can write it as C6H5 and CH2OH. So it is a so it is cresol. So it is actually it is a so it is so it can be a should be a meta cresol. It means that it is methyl phenol. Methyl phenol. So it is meta cresol, means it is CH3 and here OH. C6H5 CH3, it will be CH3 OH. Sorry, C6H4 it means. Okay. So it will react with bromine water, bromine water, and then it will form a, so here a tribromo derivative will be formed. A tribromo derivative will be formed here, which is like this. Br, 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 and this is CH3. So here a tribromo derivative will be formed, which is the compound B. And this this meta cresol only, it will be insoluble in NaHCO3 and it will dissolve in NaOH and it will give a characteristic color with FeCl3 solution. So option B is the correct answer. Then here it is told that CH3CHO, which is ethanol, which is ethanol that will react with methyl magnesium bromide. Yeah. With methyl magnesium bromide in the presence of H3O plus, it will give the compound A. So it will give CH3, CHOH and CH3. which is the compound A. So it is propane 2-ol. Propane 2-ol will be formed. Since why from here this CH3 minus it will attack here, and from here H plus will attack here, and so it will this pi electrons will go here. So here it will form CH3CO um, minus CH3 and here H. So this H plus will attack here and it will form propane 2-ol. And then when concentrated H2SO4 is used and it is heated, then here we will have dehydration reaction. It means that here H2O will be uh, removed and then it will form an alkene. So it will form uh, propene. Propene will be formed, which is the compound B. And then here B2H6 mm, B2H6 with H2O and OH minus is used, which is called as hydroboration oxidation. Hydroboration oxidation is used. So hence it will form uh, 1 degree alcohol. 1 degree alcohol will be formed, which is CH2 CH2OH, which is prop uh, propane 1-ol. Propane 1-ol will be formed. So which is the compound C. And then here it is told that A and C are. So A is propane 2-ol and C is propane 1-ol. So obviously they are position isomers. They are so it means therefore so A and C are position isomers. Since why in A the alcohol group is attached to the second carbon and in the C the alcohol group is attached to the first carbon. So they are position isomers. So option B is the correct answer. Then here it is told that the major product obtained when ethanol is heated with excess of concentrated H2SO4 at 443 Kelvin is the major product obtained when ethanol the major product obtained when ethanol, which is CH3CH2OH, is heated with concentrated H2SO4 at 443 Kelvin. It is heated. So here there will be dehydration reaction. So it means that H2O will be removed and it will form an alkene, means it will form e ethene. Ethene will be formed. So option C is the correct answer. So it is a dehydration reaction. Then here it is told among the following, the products formed by the reaction of anisole with HIR. So anisole means it is methoxybenzene. It's called anisole. So it reacts with HI to form. So from here CH3 plus will be formed and O minus will be formed and H plus will link with this oxygen and I minus will attack on the methyl carbocation. So from here methyl carbocation is formed, which will link with the I minus and it will form CH3I, and this H plus will link with the phenoxide ion, and it will form phenol. Phenol will be formed. So it will form phenol and iodomethane. Iodomethane and phenol will be formed. So option C is the correct answer. Then it is told an organic compound with molecular formula C7H8O, it dissolves in it dissolves in sodium hydroxide, and it gives a characteristic color with FeCl3. It gives a characteristic color with FeCl3 with ferric chloride solution, and on treatment with bromine water, on treatment with bromine water, it gives a tribromo derivative. It gives a tribromo derivative which is C7H5OBr3. Then this compound C7H8O is what that we have to find. So here obviously C7H8O, it should be meta cresol, since why, if it is C6H4 and then here we have a methyl group and here the alcohol group, then it will react with bromine water. With bromine water it will react to give a tribromo derivative, which is like this, OH, and here Br, here Br, and here Br. So here a tribromo derivative it will give. So hence it should be meta cresol. It means that it is meta methyl phenol, meta methyl phenol, or you can say it as meta cresol. So option A is the correct answer. Then it is told in coal-base reaction the reacting substances are. So coal-base reaction, in coal-base reaction, or it is called the coal-base electrolysis. Coal-base electrolysis. So here the phenol that will react with the in the presence of sodium hydroxide, it will form the sodium phenoxide. Sodium phenoxide ion it will form, and here it will react with CO2 and H plus ion. So the H plus ion will link with this phenoxide to form um, the OH group here, and there will be a carboxylic acid which will be attached in the ortho position. So in the ortho position, one carboxylic acid group will be attached. So here it means the reacting substances, they are phenol. No, in coal-base reaction, so Here, the reacting substances, one is the phenate, sodium phenate, and the and CO2 and carbon dioxide CO2 is are the reacting substances. So option C is the correct answer. So phenol is not the reacting substance, but here the sodium phenate and carbon dioxide are the reacting substances in coal-based reaction. Then it is told that which is most viscous, which is most viscous. Now the first one is ethylene glycol. Ethylene glycol, the structure is so the ethylene glycol structure is CH2 CH2 OH OH. It's called ethylene glycol, and then glycerol. Glycerol is like this: CH2 CHOH, here CH2OH. This is called glycerol. And m- m- methanol is CH3OH. This is methanol. And ethanol is CH3CH2OH. This is ethanol. So the rule is that greater is the number of hydroxyl groups. So greater is the number of OH groups which are attached, greater is the viscosity. Greater is the viscosity of that compound. Greater is the viscosity of that l- liquid. Greater is the viscosity of it. So here it means here methanol and e- ethanol, it has only one OH group, so they are less viscous, and ethylene glycol has two hydroxide groups, two OH groups, so it is more viscous than methanol or e- ethanol, more viscous. And since glycerol has three OH groups, so it is the most viscous among all these four compounds. So it is the most viscous. So glycerol is most viscous. So option B is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter alcohols, phenols and ethers. So still any doubts if you have, then please write that in the comments section. We shall obviously clarify them. And also please install our Sapience Education application, where we shall upload some important questions on every chapter of uh, chemistry, which are based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.